introduced, for example, in 0.5.0, right? So if there's something that you are not sure about, so we can have this discussion here, right? And also we can also discuss some also very interesting backstories. So why this feature is implemented this way and why this API looks like this. So these are all welcome. So basically, it's kind of like an internal meeting, but we also make it public. So as you can see in our attendance, in our participants, we have internal developers, but also we have a lot of people from the outside. So that is pretty fun, right? And in the meanwhile, so besides Zoom, you can also join the engineering all hands from the YouTube, but that's only one-way communication. So basically, it's like a broadcast. And so we will also record this meeting, and afterward we will upload it to YouTube, our YouTube channel. And if you haven't followed that, so you just search GINA AI on YouTube, and then you got the channel, and then just click on the follow. All right. Okay, so before we talk about all the interesting engineering problems, there are something like I want to talk to the in-house developers, in particular because this month we have we have quite some new developers onboarded in September, and so I like to explain how the life cycle of a pull request looks like in GINA, right? So because in GINA we are open source software company, so most of the time we work with GitHub, right? So basically, the one of the cool part of using GitHub as kind of the infrastructure of the company is that so basically everything you do is kind of transparent. Public is visible to the outside. So basically that means the quality of your code and also the attitude of how you handle the pull request, how do you handle the community request, actually is also visible. They are also visible to the community, right? And so this requires ourselves to be a very high standard on both engineering and also on the community relationships, right? So basically, how we handle the pull request will become let's say the role model, or will become at least visible to the outside. So this is very important that we handle our pull request in a very responsible way, right? And so I'm going. So I just listed here the steps that. Usually this is how we handle. This is how we should handle the pull request. So let's say we start a task, right? And then you make the pull request. You make a pull request immediately, right? So basically just commit some lines of code and then mark it as a draft, right? So this usually just take you 1 hour, right? So you start by first writing something, and then you immediately make a pull request and mark it as draft. So draft is a function that GitHub provides. So you can mark your unfinished pull request as a draft instead of putting work in progress, WIP, this kind of thing in front of your PR, right? And then you commit your progress frequently, and don't forget adding tests oh yes, I also put some notes here. So basically, I make a pull request and mark it as draft. This is very important as it keeps your work transparent to your colleagues and also to the community, right? And otherwise, it's kind of like there will be some conflict. Let's say you are working on that, but the people don't know about that, right? So they basically work on more or less the same thing, or the community are not aware about that. So they basically contribute more than the same thing. And to commit your progress frequently, basically you can consider commit as a kind of like as a replacement of the save, right? So you every time you want to save your code, you just commit it to the pull request, right? And also don't forget about adding tests and docs, because this not only ensures the quality of your code, but also like easing the reviewing work, right? So let's say afterward you ask people to review your pull request, And if they found out you have already a very comprehensive test and documents, so that's a big yes, right? So that's already a good sign on your pull request. The other thing that I found a lot of like a junior engineer often makes a super big pull request, which makes very hard to review, right? So let's consider you commit more than 1,000 lines of code in just one pull request. It looks like you are just trying to finish a job, right? But you are not really trying to let others to review your pull request in time, because nobody. It takes some let's say it takes some courage to review a very long pull request, right? So try to keep the size of your pull request. And usually, if you have a pull request that spread over like hundreds of files, like thousands of codes, so this is usually a sign that the task that we defined in the first step is not concrete enough, right? This is too big, right? This is not in the correct size. So usually we want to decouple the super giant task into smaller pieces and then solve them independently, right? And so next time when you found your pull request super big, then you basically have to take a retrospect and think about, okay, so is this task is defined too big, too ambitious at the very beginning, right? So let's make it better in the next time. Okay, so and the sixth and the seventh step are super important, because I see a lot of our engineers just stops there before after making the pull request. They seem that their journey is ends there as a fifth step. But actually it's not, right? The full life cycle involves not only makes a pull request, but also having it reviewed and merged, right? Only when it is merged, then you can drink a beer, you can relax, and you can say, okay, so this task is done, right? Before that, if a pull request is not reviewed, right? If a pull request is not merged, then this is not done, right? So this is still ongoing job, right? So this is super important, because when you control, when you plan your work, when you plan your daily work, when you plan your weekly work, right? You have to plan, you have to consider the time, you have to estimate the time by including all the steps that I listed here, right? Not only until the fifth step, but also including the time that people will review your work, and also the discussion that generates by this pull request review, right? Please do consider that. Please do reserve 1 or 2 days for step 6 and step 7, right? And also like I found in multiple times that we have a pull request pending on the repository for many days, and nobody really like time box it. Nobody really care when do we want to merge it, right? Please be responsible for the merging of the pull request, because it is your pull request, right? Until it merges to master, right? It's the job is not done, right? So you have to push it forward. You have to be responsible for the pull request. You have to take the ownership, and basically time box the reviewing and discussion process, and merge it into master as soon as possible, right? Only after it merges into master, this is considered as your accomplishment, and this is considered the job is done, right? And also to those who reviewing others' work, this is a very good opportunity to collab with your colleague and collab with your community. Oh, by the way, so the reviewer is not necessarily come from the internal developers. If you found someone who writes this part of the code, it's from the community, right? Please don't feel shy. Please invite them. Keep them in the loop, right? Add them using GitHub add this function to add them. Keep them in the loop, right? And so this is super important to work with the community, not consider this as a pure in-house software, right? We are not like that, right? So we have to work with the community all the time. Right? Okay. And also to the reviewers, the in-house reviewer, please note that reviewing others' work also helps you to understand the others' mindset when they develop this thing, right? Also improves the communication skills with your colleagues, and also it is part of our job duty for the engineers. Okay, so finally, when it comes to merges, right? So I want to explain this at 2 sentences here. So after you review the pull request, so how do you make it as ready for merge, right? So you basically review the change and click approve here, right? And afterward, you jump to this step, right? Okay, so now I see a lot of pull requests stays on this step, right? It seems that basically like they are waiting for me to merge the pull request, but you don't have to wait for me, right? Once it turns to this green button, right, you just click on that, right? Everyone has a permission. Every in-house developer has a permission, and also I believe everyone in the contributors of the everyone who considered as contributors by the GitHub, right? So they also have this privilege to merge the pull request. But I have to check. But usually for every one of us, for in-house developers, you all have this permission to click on the green button, right? And so this has to be noted. Okay. Okay, so that's basically concludes the first thing. So basically, you see, we actively using GitHub, and we have our Slack channel, we have our in-house Slack, we have our community Slack. So when you do your pull request, when you work on tasks, please keep your voice up, right? Please keep your others informed about your progress, about every technical details that you made, every technical problems that you raised in your pull request. We have to notice that our team is asynchronized distributed team, right? So it is very, very important to keep your voice up on your work, right? So this is super, super important. And it will also set up a good example to the community, to the open source community, how we work as an open source company, right? So this is very important. And also time management on the pull request. So usually don't make a super big pull request. Usually 80% of the pull requests can be done in 2 days, right? Of course, this is just my experience. You cannot find this on the internet, but nevertheless, I believe 80% of the pull requests can be done in just 2 days. If it cannot be done in 2 days, then probably you over-promise something, then probably the task at the very beginning is too big. And then you have to learn to decouple this into small pieces and make it doable next time, right? Okay, so this is about the first engineering culture thing, is take ownership about your pull request, right? I see a lot of people, because I see in the past months, we have this situation where nobody take care of the pull request. And so now I want to clarify the life cycle of the pull request. Okay, the second thing is also about the engineering culture, is about multitasking, right? So basically, multitasking is super important for every one of us in GINA, right? Working as engineer, right? Because you know, GINA, first of all, is a framework, right? So when you join GINA, you already have you should expect that you need some time to learn GINA as a framework, just like you need some time to learn TensorFlow before you write the first TensorFlow program, right? So we are not as big as TensorFlow, but our ambitions is basically the same, right? As big as TensorFlow, right? So when you so basically. So the fastest way to learn GINA is actually learn by doing, right? And it's actually learn by doing with multitasking, right? So let's imagine, so when you first join GINA, this is your knowledge. This is the scope of GINA, and this is your knowledge about GINA framework, right? When first on board. And so one day you say, okay, so we have a nice product manager, and in the sprint, you get 3 tasks in the current sprint, and then this is basically you want to finish, you want to get it done in the next 2 weeks, right? And if you work one by one on these 3 tasks, then most likely, right, because you don't have so many experience in GINA, right? So most likely is that you overshoot on one direction and later you lose control over time, right? And also, it could be very frustrated because in the end, if the results is not good, then you basically say, yeah, why did I waste the time on these 2 weeks, in the last 2 weeks, right? And also, if you just go one direction, it could lose, you could lose the big picture of the GINA, right? Because during these 2 weeks, GINA also expand, right? The scope of GINA also expand from time to time, right? So the best way is to work on that is to have this kind of multitasking mindset, right? So you work on 3 tasks simultaneously by using some kind of, this round robin scheduling, right? So you basically cut your time into pieces and work on 3 different things together. So in this way, you know more about the global picture, right? So basically you can see the area that you covered is larger than the area if you just go one direction, right? And also the progress that you make on one direction could shed a light on the others, right? So we hope that in the end, so these 3 tasks could reinforce each other to help you get it done in much faster, right? So this is why we have to work in this way. So basically, we have a lot of resources to help you work in this way, right? So we have different Slack channels, right? So those are all public, right? So you can join every channel that you feel interested in and you feel related to the tasks that you are working on, right? Join the discussion, right? Actually join the discussion and actually actively push forward on each direction and found the connection between those directions, right? So usually when we have this task, right? So those tasks seems very independent, but they do have some interconnections in between, right? And also remember that right now, GINA is still a very small framework compared to TensorFlow, compared to PyTorch. So it is still a very good chance for you to know, to get started, to get to know the global picture, right? So when GINA grows bigger and bigger, right? When we go to cloud native, right? When we add a lot of Kubernetes features, the knowledge that you want to learn in short time could be very, very overwhelming, right? So this is just like a TensorFlow and PyTorch. When you first see that, the knowledge there could be very overwhelming, right? So try to learn fast at this moment, because this is really a very good chance to get the whole picture of GINA. Not only GINA, but also GINA Hub, GINA Dashboard, and all the connections between all the technology stacks that we have. Right. Okay, so that's it. So that's basically the engineering culture that I want to share. And so let's move to the questions. So what are the questions do we want to discuss today?
I have a question, Han.
Yes.
We face, with the growth of GINA, we are facing continuously, and we expect to face more requests from community and more issues. Is it a plan to add a set of debugging tools? How do we expect people to be autonomous on debugging GINA apps?
Yes. Okay, so this question is about, so basically, can we provide some tools to help people debug GINA, right? So right now we don't have, and right now, so we basically have a unit test framework. We have a lot of unit tests and integration tests, which relies on PyTest, right? But I also noticed that a lot of framework, including even Flask, right? So they provide some kind of scaffold or helper function to allow people to mock their part of their functionality and to test their framework in a more efficient way. So I can imagine that in the future, we can provide another module, right? So basically called GINA testing, right? So we basically create another module here and called GINA testing, right? And in this testing, we add some more, for example, the mockup, for example, the helper class or the helper function that helps people to test in a very in a unit test way, right? So this is something that we can do. The other thing that we can do in the future is basically provide a integrated, not integrated, but provide an all-in-one test environment using Docker container or Docker image, right? So right now, so if you look at the, for example, if you look at the extra requirements. Okay, so if you look at the requirements, so we don't have, so we have the core requirements. So these are the setup. This installed on the host machine, on the host by default, right? So those are the 6 dependencies that we have, and all the others are for example, for development. Sometimes is for hub, executors, and there are some dependency for testing, right? So we can wrap this thing into a Docker image and then basically enable user to test their, for example, test their executor or test their local branch inside the Docker container. So this could be another way. Right? Yes.
One suggestion that I would have, so what I see when I tested GINA is that we describe the flows usually by describing the building blocks of the flows, but it's really hard to grasp the data structure behind the individual, after each step. It's really hard to get an understanding how the data looks like. And it would be nice to have for testing or debugging some of the features that we see after each step. How does a small piece of data looks like in order to understand, okay, what's really happening? So at least, so I come from classical search, it's really hard for me to understand how data flow through the whole system because there's no direct visualization or.
There is. We have dashboard.
Just haven't seen it.
We have dashboard, right?
Then I haven't used it forever correctly until now. Then sorry for this.
Yeah. So if you are not, so basically there, so if you, so given a flow, right? So a flow YAML, so this is not flow YAML, this is executor YAML, right? So if you have a flow YAML file, you can go to dashboard and using this visualization tools to nicely visualize the flow, right? So basically if you, for example, if you go to, if you use hello world, so you can GINA log profiling, hello world log server. So this basically starts a log server and it also connects to the dashboard. So let's go to the dashboard. Okay, so now it's connected and shows the logs. So you can go to flow design and you can actually see how the flow looks like, right? So this is, if you haven't get in touch with this, please do, because this is super important feature. Is actually it's an independent. It's a separate project that we have at the moment. It's the GINA dashboard. Right. So as you can see, so in the last few months, Sergi has already made a lot of improvement on this, and now you can see not only the flow, but also look at the the individual YAML of the executor. Previously when we have this, when we go to the GitHub. So if we go to here, right? So this is our previous version. We can visualize this using dashboard, right? So, but now you can, but here it only shows the flow level YAML, right? Now it shows also the internal. So what each pass looks like, right? But of course, this is not the final form. So for all the community listener or audience, don't be afraid. So we have a certain, we do have a certain sense on the UI and the UX perspective. So this is not really the final form. But as you can see, we do can inspect each executor or each part in a very comprehensive way, right? All right, so other questions?
Hey, hi, Deepankar here.
Yeah.
One question. So we've been discussing about the recursive document structure since the latest release. Can you shed more lights about what do you mean by going wider versus going deeper? Yeah.
So basically, I completely ruined this graph. So we have to we have to look back to the original one, right? So basically, in the since 0.5.0, so we introduced this recursive structure, right? So basically, on each document, you can work you can visit a document.chunks and then document.chunks.chunks, right? So basically, this is recursive in terms of the depths, right? So you can go deeper, so to get more granularity, right? By the way, so we later changed the depth to granularity, right? So because we really want to emphasize that the semantic structure of going deeper, right? So what does that mean by going deeper? So basically, this is so we have a smaller and smaller granularity. And so this is one thing. And apart from that, we have an orthogonal property for each document. It's called matches, right? So basically, for each document, you have some top K matches, right, which somehow related to this document. And besides that, so basically the matches can also has its own matches, right? So you can recur on this direction, right? And so this basically gives you the top case of this. For example, the first degree gives you the top K neighbors, and then the second degree gives you K times K neighbors, right? Because for each top K, you get another top K neighbors, right? So if you found all the second degree matches, then it in total gives you K times K, so K squared, right? K squared matches, right? So you can imagine this goes exponential. Wow, well, that's how recursive works, right? But also, so in terms of the depth, in terms of the widths, they all go exponential, right? Exponential, and so this is how it works, right? So basically, and also there's another thing that I want to emphasize is that these two properties. So right now we call this granularity, and then here we call this adjacency, right? Adjacency. So the adjacency and granularity are two orthogonal properties, right, of a document, right? And so, for example, if you can take the granularity at the level 2, right, at this level, right, and then go wide, right, and then basically you see, oh, what is this chunk the top K matches as about, right? And what is the top K is top K, right? So at any arbitrary, at any granularity, you can visit their matches, and the same goes for at any matches. At any match, you can go deeper to visit its chunks, right? To visit its lower granularity, right? And so if you haven't looked at the examples that we show that I posted yesterday, so if you go to so if you go to GINA example, so there is an example that I posted. Where is it? High order matches, right? So this is the example that I use this matplot to plot this, but this should be very intuitive to understand, very straightforward to understand. So basically, this all the dots that you see here is the the index, the index, the document in our index, right? So all the dots, despite the colors, right? And the right one, this right one is a query, right? And all this green one is a matches from the first degree, and then this blue one is from the second degree, and then the yellow one is from the third degree. Right? So this can be done simply by using our new traverse function in the driver, right? So if you go to so first of all, you can get all the apps. So you can get how it works here. So you can see it is pretty simple, right? So it's basically what does it do is basically you randomize like a 500 data points with 2 dimensions, and then you index that. Right? So here your index is here you index them, right? You consider each document has an embedding of dimension 2, right? So you index is 500 documents, and then you randomly pick one as a query point, as a query doc, and then search, and then search, and then as a callback function, you do the plot, and then plot is made by matplot, right? So this is pretty simple, right? Pretty simple. And okay, so this doesn't look very, very complicated. So rather it's basically running the flow and then plot, right? So but how can you retrieve the match and matches, right? So this is basically defined in the driver, right? So if we look at the driver, so this test adjacency, right? So this is our usual NumPy index, right? So it's basically just stop at here, right? And now we basically add another. We modify the search request, right? So all the other this part of the driver and this part of the driver is unchanged. We modify the search request, right? So the search request is basically, so first of all we visit the current query document, right? So we retrieve this top K, the 50, right? And then we basically recur on matches. Right, and then we basically define, okay, so what is the levels that we want to start with and the stop with, right? We only recur on this particular range, right? So in this way, we can retrieve the first neighbor, the first degree neighbor, and second degree neighbor, and third degree neighbor. So this, by the way, so this range is a right exclusive, right? So it doesn't include the 2, right? And so this is how we implement the recursion, and also how at least on the matches level, right? So right now this is very experimental features. So basically, last time Joan asked me, and also Nan asked me, what is the use of this feature, right? Why do you want to retrieve a high degree matches, right? So my answer to that is that don't restrict yourself on the search results. So when we search on Google, right? So search results always looks like a list, right? And of course, this looks like a top K list, right? But this does not necessarily define how the search result should look like, right? The search result could look like a graph, right? And so if it is possible that in some scenario we want to retrieve not only a list but also the neighborhood graph, proximity graph of your query, right? And so in that case, this could be very, very helpful. And another example is that so for example, Google has this kind of functionality. So when you search for orange, right? So let's go to image search. When you search for orange, it shows you the top K, right? And once you click on this picture, it basically use this picture as a query, and it shows the top K is top K, right? And so as you can imagine, so this immediate response, right? I mean, I don't know if Google sends another query to this, using this picture, right? Or it basically already cache the result in the current payload. So basically, when I retrieve this one, so it already has already the top case, right? Top case, right? But this could be a very interesting use case. Basically, it can provide an immediate response when you want to, for example, work on have the second degree lookup, right? So this will gives you immediate response, and it actually improves the user experience, right? And based on that, you can basically do a lot of very interesting things, such as a prefetching from the UI perspective, right? So basically, you always look for the second degree. You always look for the first and the second degree, but you only show the first degree every time the user input the query, right? So when the user traverse on this top K list, right? So they can immediately get the result, right? But what they don't know that is that when they send this thing as a query, right? So you again fetch for another second degree neighbors, right? By using this strategy, you can provide a very smooth prefetching mechanism on the front end using this high order degree matches, right? Yeah.
Makes sense. Thank you.
Okay, so other questions?
Yeah, perhaps staying a moment at exactly this graph that you just mentioned, where you can go either into the depths or into the granularity or adjacency. Is your vision also that you somehow can go both, not just once, but perhaps several times? So I could have adjacency one, and then I go down several in granularities. Let's say granularity 0 is a page, and I go down to the sentence level, and then I go again adjacency. So is this something which we might want to provide in the near future, or is this rather something which is in the like distant future, to be able to walk past, not just
I would say
one or the other direction?
Yeah, from the framework perspective, I of course wish that we can have this very general traverse, right? So basically, very exhaustive traverse, and so you can go back and forth on this graph. So first of all, this graph is pretty big, right? So if you consider as I mentioned, right, if this is top K, then the second degree is already top K is already K squared, right? And this K cubic, right, on the third degree, right? So this is a pretty big graph, and on each match you have also the chunks, right? So this is a super big graph, right? And I would say, in general, we do wish to have this kind of traverse. So basically, you can go down and then go wide, and then go up again. This kind of thing. But let's work on some examples first, right? So let's see how many examples require this kind of very exhaustive or general traverse algorithm. So my feeling is that. My guess is that usually you just fix the one axis and then traverse on the others. Right? For example, you just fix the granularity to 3, right, and then traverse on the matches, right? Or fix on the first degree matches and then just traverse on the granularity layer, right, on the granularity axis, right? So in most of the cases, this should be enough, right? And yeah.
Thanks.
All right. So other questions?
I have another question, Han.
Yeah.
Regarding in the hub, we have a few executors that we cannot provide right now a default working pod for them, for the community to work directly, because they depend on some pre-trained models. And I don't know how do we plan to take care of this kind, because I feel that it should be a general pattern in the future to depend on pre-trained models.
Yes. So basically, for those who don't know, who didn't follow on the hub progress, so basically we did a lot of refactoring on the hub by basically decoupling the hub from the core and maintain it as a sub module in the core. So the details of this kind of refactoring, this refactoring can be found in this post. Right? So you can look at how the GINA core and GINA hub is positioned and are maintained, and then how are they connected. Okay, so this is for the background, but then afterward we also build up GitHub action and use it in our CI to build this thing, to basically build and test this thing. Right? But in the end, as you can see, we have about 64 executors in the hub, and the remaining 6 executors that cannot be closed is those encoders. And it's very funny that all of them require some pre-training model. Right? So basically, this is the reason. This is based on the. This is because we didn't define any particular logic on how to load the pre-trained model, right, and how to test them. So an easy solution would be basically defines in the file bundle or cookiecutter, saying that okay, so instead of config.yaml, you should also provide a test config.yaml, test minus config.yaml, right? And then basically in the build and test, we basically use this test minus config.yaml, right? And then basically use this config as kind of the testing, right? So for those who don't know what I'm talking about, is basically so you can use this cookiecutter GINA hub, or you use the GINA hub new to create a new hub executor, right? And then this will basically download this cookiecutter and then basically create this file structure and also all the templates for you, right? And here you have this cookiecutter config.yaml. So this is basically this is positioned in this is placed in the entry point of the Docker file, right? So if you go to the Docker file, you see that this config.yaml basically points to the file that I just showed, right? So maybe we can also add something like, for example, here like a test config, right? Or not here, because we can anyway we can override the entry point here. So maybe in the GINA AI in the hubbuilder. So hubbuilder is a GitHub action that we use to test this thing, to build the image. Right, so maybe we can add it here, right? Here we have the GINA hub build, this kind of thing. So maybe we can override the entry point with the test config.yaml, right? So to make it to say that okay, so when we make the test, okay, so actually it should not be here. It should be in the hub.io, right? It should be in the Docker in the hub.io, right? In here, right? So basically here. So when we use this image, we can also define the entry point. I think it's called use internal, right? And then we basically add use internal here, and then config minus test minus config, and then use that file, right? And for the testing, right? So this could be a solution, right?
Okay, thanks.
Okay, so other questions from the community? Alex, I think you have a question that you just mentioned in Slack, right, this morning. Okay, Alex.
Yes,
probably.
yes, I did. I was just unmuting myself. So recently, some tooling that relied on GINA got broken by GINA's breaking changes. So to stop that happening again, what are some best practices we can use when building or modifying tools like cookiecutter or any others that may rely on GINA?
Yes. Yeah, so this is a good question. So it comes from, so this can be solved from two perspectives. One is basically we actively maintain a best practice by declaring what are the breaking changes, what are the upcoming breaking changes, right? So now from 0.5, we actually have this table, migration guide. So basically, now you can clearly see that, okay, so what is the change of some certain fields and the certain names of in the API, right? So this can be, so all the cookie cutter, all the other let's say other examples, they should refer to this migration guide if you want to keep this updated. But of course, the best way to have it, the best way to be immutable to those changes is having the version defined in your requirements, right? So basically in your requirements, for example, let's say this one, right? Where is my file? Okay, here, right? So basically here, as I said, so I know this probably will change in the later version. So I basically use this equal to force. When install GINA, please only install on this version, using this version, right? So this is a first step to freeze the dependency, right? So in the Node.js, in the npm, they also have this kind of requirements, this kind of best practice. But unfortunately, I don't think in Python community, this is really, let's say, well educated to the community, right? So a lot of people, I see a lot of people write something just like this, right? Without providing a particular version of that. Also, so besides that, we can also use Docker image or Docker container to build to basically ship your examples, right? So this is actually a very recommended way because once you build it into an image, right, it is immutable to the outside world. Right? So it's this is another way, right? And another thing is basically yesterday I talked to Rutuja on the cookie cutter GINA, and I found that there are a couple of things that you should not include in your own project in order to be immutable to the changes. So basically, if we look at this, if we look at the paths, for example, here. Right, so if we go to chunk, let's see the history here. Okay, so maybe not part, but for the indexer, let's see the craft encode. Okay, so basically so this is not very easy to look at because I cannot find I cannot find the previous version anymore. But basically in the previous version, Rutuja writes something like including the drivers here, right? In the encoding in the path, right? So basically, I do not recommend you to include the driver in the part level YAML, right? You also don't need to copy paste it from other examples, right? So usually the driver is on the low level, and you as the app developer, should not. It's okay that you are not aware there is a driver there, right? So unless you want to do some very fancy things, for example, like this crafter, right? So this crafter basically, this one requires a specific driver, right? So by the way, so if you don't define this request on, right, it will basically fill this in with a default value. And what is the default value of this one, right? So it will basically look at the resources. It will basically look at the. So if you go to GINA resources, right? So here we have a lot of predefined executors and also predefined driver combinations or driver group, right? So this is, for example, this is let's look at the base encoder, right? So this is a driver that predefined for any encoder that inherit from the base encoder. So who are inherited from the base encoder? Nearly all of them, right? So nearly all of them, nearly all encoders are not nearly, basically all the encoders are inherited from the base encoders, right? So they all inherit this in the request on, right? So basically, this is why when you define something in GINA-hub, right? So if we go to GINA-hub, this is the reason that why you don't need to. So let's just randomly open one thing, right? So this is audio monophore. I don't know what it is. It's a contributed by our community. So this is probably like audio processing something, right? So this here you don't write. So basically what I mean is here you don't write request on, right? You don't write something like this, right? So why? Because you know that the audio monophore is inherited from the base crafter, right? And here we already have a predefined driver group for the base crafter, right? So all the base crafter, all the crafter that derived or inherited from the base crafter should follow this kind of driver group. And so basically it will look up based on the inheritance tree, right? It will look up based on the inheritance tree. Sometimes it stops. So for example, here we have the data URI PB indexer, right? So this defines this particular driver. And of course, if you miss on this, right? So if you are not inherited from that, right? It will basically fall back to this one, right? Base index. Right? So this is how we define the driver group, and this is how we so basically, so when you start with your new or your own executor, that's why you don't have to specify this thing. Right? So if you specify this thing, then you are facing some dangers to be affected by the recent change in the GINA master or GINA new version and the GINA new release, right? But sometimes this is inevitable, right? This is inevitable. Sometimes I just want to do some fancy work, fancy tricks, right? For example, here I said, yeah, I don't want to start with two crafter, so let's just combine these two crafter together in just one executor, right? So then here it works in a chain. It works in a pipeline. You just chain these two things together, and it works in a pipeline, right? And but if you don't do that, right? So this works as a pipeline, right? So that's no problem. But the things here is, right? In the index time, we want to work as image read and image normalization as a pipeline, right? Sequentially. But in the search time, we want to first do some conversion, basically convert the URI that we received to a buffer, right? And then we do image read and image normalization, right? So just because of this simple step adding, so we have to write down the driver group again here, right? But specifying, okay, so in the search request, please don't follow whatever right in the index request, please do something like this, right? So basically in the search request, okay, we'll follow this kind of driver and we'll work in the chain, right? So only in this case, so basically this is a very specific case. Only in this case, we will you have to write your own drivers using request on. But let's say in the future, if we found that this pattern is very, very general, right? A lot of applications using this pattern, right? And we probably will promote that into the core, right? So you don't have to write this by yourself again, right? Okay, so to sum up, right? So basically you have to use requirement.txt to freeze the version, or you use Docker file, Docker image or Docker container to make your whole file bundle or whatever immutable to the outside world. Or when you write something, when you write executor, when you write when you create your own executor, you don't need to add request on this kind of driver group in your YAML file, because this is really sensitive to the change on the new release. And in the meantime, we also provide a breaking change list where you can follow on the upcoming changes. Right. All right. So, any other questions?
Nothing from me.
So is there any questions from the community? Okay. Han, so I think maybe you can elaborate more on how a flow is running, like how and when a driver is called, and the same as the executor. So when and how a driver and the executor is called when you're running a flow. I found a lot of people actually got lost here how each driver and executor is called when they are running the flow.
This is not really. This is actually a big problem, right? So this is a big question, So to answer that, so first of all, you have to understand flow and executor, they are not on the same level, right? So there are we have. So let's look at the 101, right? So I think we have already explained this. So to first understand what is GINA. So basically, this question is about the design principle behind the GINA, right? So basically, so this is the flow is on the very high level, right? It's probably not the highest level, right? Because in the future we will probably also optimizing the flow on the easy to use side, and even provide another abstraction based on the flow. So flow is but anyway, so as a current status in the current GINA version 0.5, flow is probably at a very high level. Right? So user, when they first use GINA, they will use flow API, right? And use the flow API to compose the paths together, right? So the lower level is basically the paths. Right? So path is basically the context manager of all the P's. And it makes them to orchestrate all the pieces together, right? By providing some like a replicas, sharding, this kind of strategy, also adding some head and tails to the P, right? And P basically provides a network interface of the Docker container environment for the algorithm, basically for the executor itself, right? And the P and executor. So there are some gap between the P and the executor. The gap is that the P basically handles all the network requests from other Ps or from other parts, right? And the network request is sent by 0MQ and is sent in the format of binary, which is basically the protobuf. And in order to let the encoder, this executor, to understand what is in the protobuf, right? So you need a driver, right? The driver basically filling the gap, saying that, okay, so as an executor, you don't even have to know there is a protobuf. You just know that I gave you this Python native object or NumPy object, and you just do your things. You just do your fancy, cool AI stuff things, right? And then just hand over the result to me, right? And you don't care about how to write this in the proper form, or the proper format, and I will write. I will take the drive here, right? I will take your input and then write it back to the network layer, right? So this is the driver, right? And I think this part of the life cycle, right? So how is calling, how the flow is calling everything. So this, first of all, this is This is about the design principle. So I highly recommend everyone who has this question to first read out GINA 101, right, on this tutorial, so that to understand that GINA as a framework provides multiple abstraction, and flow is on the very high level. And between flow and executor, there are drivers, there are P's and paths. But you know, the thing is that providing multiple abstraction doesn't mean that we have to expose all the abstraction to the developers, right? So developers, they usually don't have to worry about the drivers, about the P and paths, because they are simply context manager and some converting function, right? So they use Flow API and then they work on the executor. So that's basically the most popular, the most two popular components that the developers will work on, right? And if you are interested in all the abstraction and why we design it this way, right? So you can all look at this blog post. It's called Layer of Abstraction when Building TensorFlow for Search. So here I basically describe why we provide GINA, why we ship GINA in this way, and why we provide like different layer of abstraction, and why do we want to selectively expose some API instead of exposing everything to the developers, right? And so you can also look at the what on each level, right? On each abstraction level, who are we targeted on, right? So if you are AI engineers, you probably work on the executor level, and then they probably work with NumPy and so on, right? And on some levels, for example, we use Protobuf, ZeroMQ, Tornado, gRPC, Docker, Kubernetes, this kind of thing. And they are targeted towards different user group, right?
Yeah, thank you. Very nice explanation. So any other questions from the in-house engineers?
I had a question if we have time. So wanted to understand, where does UV loop come in and where does Tornado come in the whole protocols lifecycle? I think this might take a lot of time as well. We can discuss it later.
So the UV loop and the Tornado jumps in since 0.4 point something, right? So before that, we don't have the UV loop and Tornado. The reason that we introduce, so first we introduce some asynchronous strategy on the P level. Before that, before 0.4, I think in 0.3 or something, before that, we only have asynchronization on the gateway, right? So basically, when you send something to the gateway, right, then it is asynchronous. The gateway basically do some fancy things in async, and then try to schedule the send and receive stream, and doing everything in asynchronized, right? But in each flow, on each P, right, after they receive. Okay, so this is a very technical question. So let me go to the base P, right? Okay, so basically loop body. Let's see. Okay, so basically the thing is that maybe this is not enough. Okay, so before that, let me write something here, right? So this is too small. So this is before, let's say before 0.4, right? So the P works in this way. So the P works in this way. So first it is listen. The P is listening on some port, right? And by the way, so each P has two ports. So you can ignore the control port. So one is for send, the other is for receive, right? Okay, so before 0.4, the P works in this flow, in this way. So they first receive receive message from the network, right? and it do all the handling, right? Like a calling executor, right? So basically handling by aka calling executor, right? And then it sends the message, right? And this part, this procedure is basically is repeated, right? So it's basically you use a kind of like a while, this while true, right? And then do this, right? Yes, and immediately you realize that. So first of all, this three steps here, they are synchronized, right? So basically one has to follow the other and so on, right? Okay, so a lot of people will immediately see that, okay, so this while true sounds very looks very shabby, right? It looks very like a quick word. It decreases the performance and so on, but actually it does not, right? Why it does not? Because the P actually work in the thread or process, which is apart from the main process, a part of the main process or thread, right? So in this way, the while true, this forever loop, right? This doesn't hurt the performance. Actually, not at all, right? So because from the main process or main thread, you are not suffering from the this kind of while true loop. So and also basically here it is blocked, right? It is blocked. So it's not non-blocking. It's basically blocked. It's blocked by some seconds, by some timeout. I forgot. But this is basically before that, right? And as you can see here, it's basically a synchronized workflow or synchronized event loop, right? So what can be optimized here? So basically the receive and the send, right? Notice that they are using two different ports. So they can be squeezed into one, into one time frame, right? So they can be done simultaneously. So when you receive something, you can also send, right? Although this is this is not a big, most of the time, of course, it's spending here, right? So for example, when you do the bird, when you do the whatever, this kind of thing, most of the time will be spent here, but still, right? So there is some space. Basically, the time of receive something and the time of sending something could be overlapped, right? And this will reduce the time and also the overhead in the long run, right? So after 0.4, so what did we do is basically all these things. So this two prerequisites is not changed, and also the P work in the separate thread or process. This is also not changed, but instead we introduce ZMQ streamlet, which is basically a wrapper on top of ZMQ stream, right? ZMQ stream is asynchronized. So this basically provides asynchronized interface. So basically it provides an event-driven receive and message. So basically it provides something like an on-receive and on-send, right? And then basically this on-receive and on-send, these are the, they are called in the, they are maintained in the event loop, right? And but ZMQ stream, but ZMQ stream is a module from ZMQ. It's from PyZMQ, and also it has a dependency. It depends on Tornado. So that is why we introduced Tornado, because the ZMQ stream used Tornado. I actually don't want to introduce Tornado for that, but unfortunately, it seems now they are very coupled together, right? So I think there's no way to, nor easy way to decoupling that from the ZMQ stream, right? Okay, so regarding the UV loop is just a drop-in replacement. drop-in replacement for async IO or for async in Python. Not for async in Python, for native event loop in Python, But this is pretty low level, right? Because the native event loop in Python is basically implemented with C Python, right? But the UV loop, they did something very fancy low level tricks and probably written in C or whatever, right? So it has a very good performance, right? So you can also look at the async IO here. So they basically make a side-by-side comparison with UV loop and also the async IO, right? So async IO is basically the the Python native one, right? And you can see that it has a better throughput. It claims to be two or four times faster, and it's implemented in Python, right? And using libuv, and I think it's pretty good. So you can look at the let's search for worth it, because that's only the keyword that I remember. Use hello world as a performance retry, adding UV loop, adding syntactic sugar retry conflict. This one should be. Okay, so in here, so we basically 0.3.5, right? So I replaced ZMQ streamlet with ZMQ-let. So this is basically the asynchronous strategy here. So let me put it here. So this is the before, right? So we have this kind of performance. This is based on the hello world, right? And this is after, right? This is after. So as you can see, despite, I mean, the download speed is not something measurable, because download speed is basically the network. You can see the index time after using the asynchronous version, it is actually improves a lot, right? It actually improves a lot, and also in terms of the current time, and also in terms of the throughput. So you can see the improvement here, right? And so that is the reason that why we introduced Tornado and UV loop. So Tornado is simply used in the ZMQ stream, and the UV loop is basically served as a drop-in replacement for all event loops that use in GINA, right? For all event loops, including the gateway, right? So this is actually one optimization that I'm very proud of, because this actually makes the whole GINA more scalable and more much faster than before, by using all the asynchronous this kind of mechanism. Yeah.
Thank you.
All right. So any other questions? I mean, beyond that, so basically, this is not like a press conference, right? We're not trying to. I'm not trying to answer all the questions that we have. It's not like that. So this is engineering all hands. Sometimes we can also discuss on particular features that what are our thoughts on that, right? From in-house engineers and also from the community. And it should be more interactive, right? So as I said, so this is not a press conference, and I usually don't prepare anything, right? I don't make a presentation here, right? So I just so this engineering culture thing that I have to talk about. This is because something that I like to mention, because we have a lot of new engineers on board this September. So I'd like to raise some attention. But apart from that, right? So we should really make it more on the discuss more engineering problems on the technical details on the particular feature. If you are not sure about which direction should you go, right? Or is it the best way to implement GINA, right? For example, just GINA is basically GINA. A lot of people when they first use GINA, they are frightened, right? They are frightened because the knowledge is pretty overwhelming, and sometimes a lot of people comes to the GINA repository and thinks that GINA is probably a one-liner that can solve its problem, but in the end, it turns out to be a big framework, right? So this as a big framework, so we have a lot of flexibility to achieve the same job, but with different implementation. For example, with a different YAML configuration, with a different flow design, right? But they all can achieve the same task, right? But some way, some method, or some implementation are more efficient than the others, right? So in this meeting, we can discuss about the best practice when using GINA. So this is also very, very important. And we have to understand what is the best practice. And we have to understand what are the variants of, what are the variance methods, what are the variant implementation to achieve the same task, and what are the best practice from that. Right? So that we can write better document and we can better communicate with the community about all those lessons learned, experience, and so on, right? And also, like for example, in this time, I asked one of our in-house developer to write the minutes, meeting minutes, and so that we later will match this to match the question to the timestamp when we upload to the YouTube, right? But in the future, so we can take turns on the host. So this time it is me, but next time it could be others, right? And also to the also on the minute writer, this we could also take turns, right? And so the idea of engineering all hands is really about building an open governance model, right? And I believe, Alex, you have already joined multiple times with RFAI's event, and you know how this project, how the open governance model works, right? And you see that we are still far away from that. So because this meeting is apparently right now just me answering questions. So this is not ideal, right? And so okay, so this is something that we can improve on the next time. And yeah, so apart from that, given that there is no technical questions, I want to say that, so basically right now we have examples, right, which needs to be refactored very quickly because of the hackathon. Hackathon is coming, and we have to look at it. We have to, we have a lot of examples here, but we later decide to, structured in different ways. Nana has already a plan, right? He showed me last night, and so let's proceed on this one. And also, like here we have, like, I think we have 10 story points on in this week on refactoring all the examples. Right, so this part is really as a very high priority given the hackathon is coming. And apart from that, so we have multiple events like PyData event that we are going to sponsor. And so if you have any, like, if you want to make a talk about GINA, using GINA, please do, right? You as engineer, you are the best evangelist. Not to belittle Alex's work, but you as the engineer, you can convince more engineers to use GINA with your experience, right? So this is something that, so we really expect you to stand on the stage and to talk about GINA, right? So it's the evangelist is everybody's work in our company, because we are open source company by nature, right? Right. So if you have any topic, if you have the lessons learned, interesting engineering problems that you want to share with the public, please go to Alex and fill in the form or make a titles or abstraction, this kind of thing, and so we will basically ask the PyData organizers to schedule the talk. Yeah.
Han, if I could just jump in here. Yeah. Hey, everyone. So, yeah, I created a Google Sheet. It's linked from our Slack. So just go there, fill in a row with your name and all that. I put an example row in there to show everyone what to do.
Yeah. All right. I think that's basically for today. And I'd like to thank everybody for your attention, especially for the external community contributor and enthusiasts. This is very important to have your in this meeting as well. And so that's it. And see you next month. Yeah. Okay. Bye-bye.